Assalamu alaikum. This is lecture 13 of Information and Communication Technologies, and for this lecture and the next couple of lectures I will deviate from the topics which we have been discussing in previous few lectures, and we will focus on problem solving and programming of computer systems. And the title of this lecture is particularly the problem solving and the ways to represent your problem into computer programs, often termed as high-level algorithms. So these are the lecture contents. So we will start by looking at the definition and representation of algorithms, which are a useful way to represent a set of sequence to execute a task in computer systems. The programs can also be represented graphically by the means of flowcharts, which are also part of the discussion for this lecture. And finally, we will discuss about trace tables and dry running your code to check the correctness of your program. So as I have mentioned earlier, problem solving usually consists of number of steps to achieve the desired goal. These are called the steps or sequence of steps in your algorithm. Computer programming can be divided into two phases. The first one is the problem solving phase and the second one is the implementation phase. So in the problem solving phase, you have to divide the problem into a manageable subtasks. That means making an ordered sequence of steps that solve that particular problem. So these sequences of the steps is called an algorithm. On the other hand, implementation phase is done by implementing the program or sequence steps in a programming language. So first, produce a general algorithm, and we often call it a pseudo code. And then we define the algorithm successively to get the step-by-step detailed algorithm that is very close to the computer language. Pseudocode is an artificial and informal language that helps the programmers to develop algorithms, and pseudocode is a very familiar to everyday English. So this slide will help you to understand the pseudocode and the algorithm with the help of an example. So in this example, we are given a problem task, and the task is to write an algorithm which will help you to determine the student's final grade, and it will indicate that whether it is passing or failing. Therefore, the final grade is calculated as the average of 4 marks. So the first step, you have to divide the problem into a sequence of steps, and as you can see, our description of the algorithm in the English language helps us to decompose the problem into small subsets. So at the first, we can see we have to write an algorithm. So what we want to determine is to find out the student's final grade and indicate that whether it is passing or failing. So here are two more conditions. Now we have to understand how we have to calculate this, and the next statement shows us that the final grade is calculated as the average of 4 marks. So first of all, we have to get these input marks. So if we try to write the pseudocode based on this description, we will start by getting some input of 4 marks, and then in the next step we will calculate their average, and how we can do it is by summing them all and then dividing by 4. Now we check the condition that if the average of the mark is below 50, we print that student is fail, and otherwise student is pass. So similarly, if you look at the detailed algorithm, it is much similar to the pseudocode, but it contains a more specialized language. So this is more closer to the English language, and this is more closer to a programming language. So in the detailed algorithm, we have the similar steps which says that input 4 marks, often referred as some variables, and here we use 4 variables m1, m2, m3 and m4. Next task is to calculate the grade, and we can calculate the grade by adding 4 numbers and then dividing the sum as a whole. And then we check if that grade is less than 50% or 50, we print the fail, and if it is not, we print pass. So before moving forward, let's briefly analyze the characteristics that an algorithm can possess. So typically an algorithm is usually represented as a block of code, so which is a step-by-step method for solving the problem or doing a task. And an algorithm can take some input data and it can give back some output data. So it has a definite input and output. Secondly, it is well ordered. As we have seen in the previous slide, it is the sequence of steps and all the sequences are ordered. That means they will execute one after the other. So steps are in clear order. They should be unambiguous, operation described or understood by computing agent without further simplification. They should be effectively computable. The computing agent can actually carry out the operations. So algorithms can be executed by computing agent, which is not necessarily a computer. So here are some general rules that you should employ while constructing your algorithms. So these are the rules for the input. So you should use some keywords like input or get, followed by the list of variables separated by a single comma. Such as if you want to get one input, it is input A. If you want to get two inputs, input A, B. Similarly, you can use get A, comma B. It is a good practice to show a message before prompting user for input. For example, you can say you can display some input that enter a number and then ask then print the input A into your algorithm. Similarly, for the output, you can use the keyword output, display or print followed by the variable name or text. Usually text is enclosed in double quotes or inverted commas. However, you do not have to enclose the variable name in the inverted commas. As an example, you can see if you want to output simply a text, you can see output, enter a number, and this will be displayed to the screen. Similarly, if you want to display your number is num, so this is a variable and a value will be displayed, and this is the text which will be displayed like it is written. So apart from the input and output, your algorithm may contain some operations which can have the functionality of storing or assigning values. So for these characteristics, you have to use a keyword called set in combination with equal to, colon equal to, or this assignment operator. So as an example, you can see if you want to set some variable value, you can set x is equal to 8 or simply x is equal to 8, set x colon is equal to 8 or assign 8 into x. Again, it is a good practice to number your steps and indicate the start and the end of the algorithm. So here is the example given which contains the input, output and assignment or storage rules. So as you can see, we want to input some number 1 and number 2 and output some number 1 and number 2. So in this step we say start the algorithm. In the first step we input number 1 and number 2. In the third step we calculate the sum of the entered numbers, and then we display the sum calculated and end the algorithm. So every algorithm can contain any amount of statements or sub-steps to perform a task. However, there are three common structures of an algorithm which are prevalently used across the programs to solve any particular task. So algorithm follows the structure theorem, which states it is possible to write any algorithm by using only three basic control structures. The first structure is the simple one, which we have seen earlier, is a sequence structure. So that means I have to study, for example, I have to study a class from grade 1 to 8 and there is no skipping. So you have to follow the sequence from grade 1, 2, 3, 4, 5, 6, 7, 8. I cannot skip any class in order to reach in the grade 8. There are some structures and there are some conditions in the programs or problems that require a repetition. So that means you have to perform a task for a number of times. So if I am fail in a grade, I have to repeat it until I pass. Similarly, in some cases you have an option to select from set of options and this structure is called selection. So as an example, if I have passed my 8th grade, now I have to select between the science and arts groups. So you have seen the sequence grid in the previous algorithms, and you have seen the selection structure theorem in one of the previous algorithms where we had to calculate the grade, and if grade was greater than 50%, we printed pass. So selection structure theorem is often termed as a decision structure theorem. So sometimes we need to put certain condition before performing some action, just like we did in the grade assignment. Then action will depend upon the condition if it is fulfilled or not. Selection statements help us to get this thing done. This construct represents the decision-making abilities of computer to compare two pieces of information and select one of two alternative actions. So in pseudocode, selection is represented by the word if, then, else, and if. So an if statement always has a condition to check and often a comparison between a variable and a number. The if statement also must specify what to do if condition comparison is true, and these instructions for true may come after the word then, or they may be simply listed. So there are different types of selections, such as if selection, which contains simple single if. Single if statement either performs an action if condition is true or skips the action if condition is false. Similarly, if you want to make two-way decision, you can employ if, else, and if. That is the double if statement. If else selection statement performs an action if the condition is true and performs a different action if condition is false. Similarly, you can embed multiple ifs using the double if. So in this way, you can have multiple decisions such as if, and if condition is true, you can perform option number one. Else if, and if you check another condition is true, you perform another action, and next you can embed multiple ifs, and finally you can add the else block. Then if every condition is false, it will be executed. So in the if else selection statement performs one of many different actions depending on the value of an expression, which can be replaced by the switch condition, which is alternate to multiple ifs. The switch selection statement performs one of the many different actions depending upon the value of an expression. So here are the rules for the selection statement. If you have one option, you will use the if statement and you will check the condition, and then you will execute set of steps if the condition is true. If you want to make two-way decision, again you will check the if condition, and if it is true, you will perform set of action, and if this condition is false, you will perform another set of actions. In the multiple conditions, you check if condition is true, you perform this set of steps. If this condition is not true, you can perform another condition check which is else if, and if this is true you perform this. Again, if above is false you can check one more condition. If this is true you can perform this, and if all of the above three conditions are false, this statement or set of statements will be executed. So here is another example of a decision or a selection algorithm. So we have a problem which says input the marks of student and display pause if the student marks are 50 and else display fail. So it is the similar problem like the previous one. So but in this case we do not have to calculate the average. So we started the algorithm. In the first step we have input marks, and if marks is greater than 50, that is simple if condition, then we will display pass. So we have an else part, that means it is a two-way decision. We check if this condition is false, we have to provide an option for an alternate decision which is display fail. Next we end the if and end our algorithm. Similar to the decisions, we have another structure theorem called repetition. Repetition is often termed as a loop of all which contains all of the part of the commands in a program to execute repetitively. So a loop has a counter which is a variable to calculate the number of times the loop has executed. So a loop may continue till a condition is true or until a certain condition is met, that is, until the end of while or until a number reaches to a set limit. So here is an example. We have a keyword for the repetition which is while, and we have another loop which is for loop. So while condition is true, condition P is true, we execute the set of statements and we end it when the condition is false. So there are three types of repetitions. The common one is the while loop, which is a control flow statement that allows the code to be executed repeatedly based on a given Boolean condition. So the while loop can be thought of repeating if statement until the condition is true. This will keep executing the set of statements. Similarly, do while is the variation of the while loop. The do while loop statement performs the action or a group in its body at least once. That means it will execute first and then check the condition, and if condition is still true it will execute once more and then check the condition, and so on. Another kind of loop is a for loop, which allows code to be repeatedly for a number of times. For loops are also typically used when the number of iterations is known before entering the loop. That means if you want to execute the loop for 10 times, you can have the for loop with the counter is equal to 10. So there are different types and conditions on the loop. First of all, we have a pre-test loop, which is an evaluation which occurs before the statement within the loop are processed. Similarly, post-test loop is the evaluation occurs after the statement within the loop are processed. So the step at which the loop starts is called entrance, and the step at which loops complete is called exit. So the conditional test that performs the exit from the loop should be placed either immediately followed the entrance of the loop or following all the steps in the body but never in the middle of the body. So loops with the test at the entrance are said to be pretest, which is the while do statement. Loops with the test after the entire body or post test, which is the do while loop. So it is imperative that at least one statement within the statement blocks alter the condition and eventually render it false. Otherwise the logic may result in an endless loop and you will be stuck in your program or problem solving technique. So here is an example. So in this we want to calculate the student total, and if that total is less than 10, we want to add 1 to the student total. So we set the student total to 0 and we check while it is less than 10. We read the student record and print the name and the address. So and add 1 to the student total, and in each iteration this value of the student total will increase by 1 and it will gradually execute 10 times and reach at the level of 10. So when loop condition is not met, the loop will end. The variable student total is initialized before the loop condition, which is very important step. The student total variable is incremented, which is again another important step in the loop. So it will be it will lead to an eventual stoppage of the loop. So your algorithm may be divided into some logical parts, and these parts are called modules. So which help you with the clarity and understandability of your program, and modules can be reused, so you can use a module in one program and then reuse it in any other program where necessary. So it can be reused within the same algorithm or into a different algorithm. So in programming, modules are called subroutines in older languages, or functions in procedural languages such as C or C++, and methods in object-oriented languages such as Java or C Sharp. So to build the logic, you need some kind of tools and techniques, and there are two commonly used tools to help to build the logic or the algorithm, are called pseudocode and the flow charts. Pseudocode, as described in the first few slides, it is an artificial and informal language that helps the programmers to develop an algorithm. Pseudocode may be an informal English or combination of computer languages and spoken language. So whatever works for you or the programmers. On the other hand, a flowchart is another algorithm but graphical that shows a logic solution. A flowchart emphasizes individual steps and their interconnections. A flowchart must have a start and a stop, and a step in a flowchart must connect, and you cannot leave step hanging without connections. So, for example, control flows from one action to the next in a flow chart. So here are some symbols to represent flowcharts. So if we want to represent an program or an algorithm into flowcharts, we have to use these symbols. So these are the symbols which represent the structure theorems of algorithms. So the flowchart is one of the basic methods of representing an algorithm, and it is useful as a precise method for explanation in some circumstances. A flowchart is a diagrammatical or pictorial representation of operations involved in a data processing system. So every algorithm or flowchart must have a start and end points or end steps. So in flowcharts, the start and the end points are represented in a oval shape like this. Similarly, if you want to perform an input or an output, it is usually represented in a parallelogram shape like this, or if you want to execute some step, it is represented in a rectangular block. If you want to take a decision such as a condition or a repetition, or diamond shape symbol is used. So it is used to show that the program must decide whether something, usually a comparison between numbers, is true or false, yes or no, and these branches execute based on the result of the conditions. So you can use connectors to connect between the pages. So these are the connectors, and you can use the flow direction to show how your code is moving from one point to another. So here is an example of an algorithm with a flowchart. So we take the same algorithm as described in the previous two slides. We take the input of four numbers which are marks M1, M2, M3, M4. We calculate the grade based on these marks. We calculate the sum and divide by 4, and if we check if that grade is less than 50, we print fail, and if that result or condition is false, we print pass. So as you can see, it clearly shows the start of your algorithm, the end of your algorithm. It shows an input, it shows some processing, it shows some comparison or conditions, and it shows some output. So here is the representation of all of the sequence of these steps. So as the start and the end, we have symbols here. So next is the input. So input is represented in the parallelogram, and we see input, we have to input M1, M2, M3, M4. Then we perform some processing, which is the calculation of the grade based on the input and summing those input and divided by 4. So next we have a condition, and which is represented in a diamond shape. So we check if grade is less than 50, and if result is yes, we print fail, and if result is no, we print pass, and in both cases we reach the terminal condition. So now we can understand that algorithm is a sequence of steps designed to perform a particular task. On the other hand, if you want to execute a set of tasks and check that whether the task is proceeding correctly, you want to dry run or trace the values of your steps or variables. So dry run is the working through a section of program manually, and trace table is a table constructed with the column to identify the instructions executed and columns for contents of each variables. So in computer programs, we usually have two kinds of elements to store data. So one is the variable, which is an identifier associated with the particular memory location used to store data, and another is a constant, which is a data item with a fixed value. So variable can change during the execution of programs, such as you have seen in the previous slides. The grade value of the grade changes based on the input. However, the constant values remain same, and some constant values, such as if you are performing some mathematical equations, you can use the constant value of pi, which will stay same forever. So let's understand the trace table or dry run with help of an example. So we have an algorithm which starts and sets a variable equal to 0, and then takes the input another variable which is y, and then calculates x is equal to y multiplied by 2, and then output this new variable and end over program. So let's say we print or we use this algorithm to trace our values. So let's take the each step in the algorithm and find out the values of the variables involved and the output. So at the start, you can see you have no variable, so all the values are nil. So at the second step, you set value of x is equal to 0. So you can see x is 0 and the rest is nothing. In the third step, you take some value which is input by the user. So let's say the user input for y is 5. So in the third step, we have x is equal to 0, y is equal to 5. So in the fourth step, we calculate y multiplied by 2, and y we know was 5, and multiplied by 2 is equal to 10, and we store this value into x again. So we can see we have x is equal to 10, y is equal to 5. So finally we output the x and we get the output is equal to 10, and then we end the algorithm. So let's take another example, and in this example we have an algorithm which takes 5 inputs from the user and calculate and display their sum and average. without using the loop. So we start the algorithm and we take input of 5 values: number 1, number 2, number 3, number 4 and number 5. So these values will be entered by the user. Next we want to calculate the sum, the average, and we know we have total numbers is equal to 5 and the rest of the variables are set to 0. So in the next step, so there is a slight error here. So this is a repetitive statement. So we eliminate the step number 4. So in the next step we calculate the sum, which is the sum of all numbers entered by the user. In the sixth step we calculate the average, which is sum divided by total numbers, and we know total numbers was 5. And then we print the sum is equal to sum and the average is equal to value of the average variable before ending the algorithm. So here is the trace run of the same algorithm. We can see in the start we have all the variables is equal to null. So once we take the input, we have 5 different numbers input by the user. So we get the sum is equal to 0 and average equal to 0 and total numbers we know beforehand are 5. So now it's time to calculate the sum, and we can see the value of sum is equal to 160. In the next step we calculate the average and divide it 160 by 5. We get the average is equal to 32. In the next two steps we print the sum, which is 160, and in the final step we print the average, which is 32. So here is another example which is similar to the previous example, which takes 5 inputs from the users, calculate and display their sum and average. But in this case we take the input repetitively. So in the first step we set num is equal to 0, and we set sum is equal to 0, average is equal to 0 and total number is equal to 5. So we input a number, we sum the number, again input and add it to the sum, again input, add it to the sum, again input, add to the sum, again input, add to the sum. So then we calculate the average, which is sum divided by total numbers, and again print the results. So here is the trace table for this algorithm, and you can see we have used only one number, which can be repeatedly using another value at each step. So finally we get the sum again, which was 170, 160, and the average is 32. Or is another example which again takes the 5 input from the user using only one variable input and calculate and display total sum, sum of even and average, and again without using the loop. So now you just have to change one condition which will check each number with whether it is even or not. So you can check it if you divide the each number with the 2, and if result is 0, this will be the even number, and if this result is true you will add the sum of even, otherwise you will ignore it. So we have sum of even as an additional number, so you can see we have only one number even at this point, which is 24, and then the next number is 38, so we get the sum 58, and finally another number is 18, which will add up to 76. So this time we have changed the values, and sum is equal to 170 and average is equal to 34. So that is it about the algorithm and flowcharts. And if you want to read more about the topic, you can go through the recommended books, or you can search the desired topic over the internet. If you have any further question, feel free to ask me. Thank you very much.